So just to let you know, this is part of our plans to create a set of series for teaching the tools and the methods for open neuroscience, and especially about neurophysiology. And in this regard, some of you might have been at the Odin Symposium last year, and we'll have the next symposium hopefully being held at Seattle in Allen Institute, jointly with Allen Institute. And we will also try to create a sort of seminar series about reuse of data and novel discoveries, especially with data-driven models. So that could be more technical in terms of mathematical concepts and the physics concepts behind this sort of methods. But today, Jeremy is going to teach us a little about the tools that he has created, including Neurosift and Dendro. So Jeremy is a mathematician by trade. He works in Center for Computational Mathematics at Flatiron Institute, and he has developed really cool stuff. And I won't keep him for too long, so I'll let him take this podium now and tell us about how to use these methods to reuse data, or use these methods to analyze your data, which is hosted on DANDI, and you want to share it, for example, in a limited model with like a set of collaborators, and it could be restricted in terms of its use. No matter what, you can use these tools, and it's very powerful. So, Jeremy, please take.
Thank you, and thank you, Nima, for inviting me. Like he said, my background is in mathematics, but I've sort of drifted into neuroscience, although I would say I'm not really an expert at all on neurophysiology. But I got into this area by trying to tackle the spike sorting problem, which many of you maybe recognize is quite a difficult and unsolved issue. And what I sort of recognized in my attempts to develop my own algorithm for spike sorting, as well as using other algorithms, is that we really need to have some sort of a framework to be able to compare methods and to be able to see the results of downstream analysis for different spike sorting techniques, for different parameters that are set and everything. And that is quite a challenge, because these electrophysiology data sets are quite large. There's a lot of parameters that are, takes a lot of resources to run spike sorting. There's different file formats. So a package that I'm involved with, maybe some of you are familiar with, is a spike interface, and that sort of tries to address some of these issues. But this sort of brought me to exploring the DANDI archive, because that has some public electrophysiology data sets, and then began to develop web-based visualization tools for viewing that without having to download the terabytes of data onto my local drive. And I slowly ventured outside the world of spike sorting and trying to support all the different data types that are available on DANDI and NWB. So let me just ask before I start, who has used the Neuro Data Without Borders format? Okay, so we're going to aim to have some converts here to begin using that, because without converting your data to NWB, the tools as they exist aren't going to be useful. Although we could extend these tools to be able to support other formats as well. But the purpose of DANDI is to sort of uniformize and standardize how data, neurophysiology data, are stored. Question? Yes.
So the question: are there any vendors that use it? Are we using it? We don't know it.
I don't think. Yeah, I think. I'm not super familiar with whether the vendors support natively saving into NWB format, but I don't think so, because that's usually the first step in the process of uploading to DANDI.
Yeah, and usually there are actually a number of tools which actually help you convert your format, whether you're recording from, convert it to NWB, and that's actually very good, because it's there's a lot of proprietary formats around, so everybody who builds a tool, they have their own system, whatever. but they are working with people who have developed NWB and a number of tools. And I can also guide you to those tools if you need to. And I'll create a list after that and send it to you. So it's called like NeuroGuide, NeuroCon, all kinds of things. And in terms of materials, you can also ask Ben, who's part of creating this NWB, to come to show you on that one for people who are on the experimental side. I want to come with their data to NWB because now that's coming up as an emergent sort of like a standardized method. So.
Yeah, thank you. Yeah, that's
By the way,
great.
feel free to interrupt Jeremy and
Yep.
ask questions with that said yet this session.
Question? Yes.
Yeah, if we wanted to publish data, but we only have PDF files, would we have to manually convert them to NWB or is it like an automated way?
Yeah, like Nima said, there's a growing number of tools for automatic conversion. I'm not specifically familiar with that format, but if it's not supported, we can create a pull request or submit an issue to this NeuroConv.
I think PDF is actually part of the tools that
Yeah.
Part of Pythons that are doable, so you can actually convert these. Just like a few lines of code.
Yeah, and you can either do it by code or there's this user interface called Guide, which also allows importing. So, okay, so there's a lot of opportunity to convert data to NWB. So during this presentation, it's sort of going to be motivating that. And for those of you who have laptops, there's also going to be an opportunity in this presentation to have hands-on exploration of these data sets. And even it is possible to run spike sorting on data on DANDI through your web browser. That'll be the last step here. So, okay.
And by the way, one thing I want to mention is that one of the cool aspects of NWB is that whether your data is optical physiology or neurophysiology of any kind, or it's behavioral data, whether it's combined with the physiology or not combined with physiology, you can all incorporate it into one platform. So that's another aspect. So you might have multiple recordings, like your camera, behavior, or other kinds of measurements, and, your calcium imaging, those kind of things. You can incorporate them all into one platform.
Okay, great. So the entry point here is to go to this website called neurosift.app. So I'll pause for a little bit. It's listed there. If you have a laptop, then just head over there, and that will kind of branch you off to all the different parts of this that I'll be discussing. So let me know if you have any trouble getting to that website, neurosift.app. So the goal here is to learn these tools that I've been developing in conjunction with Catalyst Neuro and Ben Dichter, called Neurosift and Dendro, to encourage use of NWB and DANDI, and to plan the future development to meet the needs of the neurophysiology community. So the objectives of these two pieces of software is to really provide a user-friendly browser-based way to explore the DANDI archive, the NWB files. Neurosift is a tool developed for the visualization of NWB files, and it also allows interactive exploration of DANDI, which I will get to. Dendro is the second tool, which is the data analysis system, where you can run containerized jobs on those data sets that are in the cloud, and you can launch those either from in the browser with Neurosift or with Python scripts. So Neurosift, Dendro, and DANDI are integrated to try to provide a seamless experience for exploring the NWB files. So it's not just a matter of convenience and ease of doing it all within the browser. I think that we can maybe appreciate that part of it. But it's also when you do things in the cloud, in the browser, the provenance is automatically kind of stored there. So you can share a link with somebody and say, okay, here's the analysis I ran. You just paste a URL, and then they can go and see that as well. So for the setup for the workshop today, if you have your own laptop, you can go and sign up for DANDI Hub. Now, I'm not sure how much time I should wait for people to do that. Who is interested in joining DANDI Hub here and following along with the examples? Okay.
So I have a question.
Yes.
I actually tried to follow this DANDI Hub, but it's just give me a 404.
Yeah, same 404.
Yeah,
or-
yeah.
orbited.
You have to sign on DANDI archive. You have to register on DANDI archive.
So
When you register on DANDI archive, you put in your code, and then you get approved.
And
And then you have access to Dandy Hub, where basically you can, it's just a Jupyter Hub. So in it, you have access to all the Dandy data, you don't need to download data necessarily, because it's all in the same AWS cloud.
Still, I get into the Dendro archive. Where do I
Oh,
register? I'm already.
here, if you go to hub.dandyarchive.org, you should see something like this once you've logged in. Yes?
Yeah, but before they have to go to Dandy Archive, and on top of it, you have to log in.
Okay.
Yes, yeah, it has to be your own.
Using MIT GitHub. Okay, I have it.
Oh, okay. I didn't realize that, yeah.
Yeah, because we want, the resources not to use random people.
Okay. Yes,
To
I
be
saw
as
that.
an account.
So, also I should mention, if you go to neurosift.app, there's a little question mark up here that you can click on, and then you get a link to this presentation. So then you can follow along, and then you've got links to everything. So go to neurosift.app, question mark, and then this presentation. All right. So while people are signing up here, it's suggested that you select for the server option the MIT Workshop server. So let me just go over and do that over here. So MIT Workshop, and then start once you're registered. And then it will take a little bit for that Jupyter instance to start up. Okay, great. Oh, the other option, if you don't want to use Dandy Hub, you can use your own computer if you have Mac or Linux. And if you have Windows, it might work. So if that's another option as well. So in either case, the first step once you log into the Jupyter Hub is to open a terminal. So you go to File, New Terminal, and then run this command, pip install these pieces of software: Neurosift, Dendro, Lindy, and PubNub. So you could just copy and paste that from this document.
You also need to install npm for the Node.js. I tried that.
Oh, okay.
You need to install npm because I don't install it.
Okay. All right.
Has everybody access to this document?
Yep. Okay, great. So you're welcome to go ahead, scroll down and go ahead if I'm going too slowly, or if I'm going too fast, you can go at your own pace. But okay, what is the Dandy archive? So this is a public repository. Right now it has 711 Dandy sets or data sets. Each Dandy set can have dozens or hundreds or thousands of individual NWB files. So right now there's 826 terabytes of data, and it's an amazing resource. This is just text that I copied from the Dandy website. It's for publishing, sharing, and processing neurophysiology data, and it's supported by the Amazon Open Data program. So at this point, they're not worried about how much, how many files and the size of the files at this point. So here's the important thing. Let's assume you lose all the data in your lab. What would you want from an archive? So you would want it to be able to basically store your data in a way that you and others will be able to retrieve it in a standardized format, so that you don't have to, what if you lose the software that can read these formats or something like that. So NWB is very standardized in that way. So it's not just an endpoint to dump the data, but it's intended to be a living repository that enables collaborations within labs, across labs, and for others. So in this spirit, this is where Neurosift and Dendro, as well as other tools, come in. So Neurosift, on the one hand, is an alternative Dandy archive exploration tool. So you can view NWB files. It runs completely in the browser, and there's no server required. So I'm not maintaining this website. It's just basically hosted on like a GitHub Pages type thing. It's a static site, and all the work is done on the client side, and it's pulling data lazily from the remote HTF5 files. So I'll mention that it's inspired by the NWB widgets package from Catalyst Neuro. So let's go to DANDI. So let me click on this link here. And we'll go to example 000552. So let me type that in, 000552.
By the way, why Jeremy is mentioning this, so the data that is in DANDI, some of them are public and some are embargoed because experimentalists might actually upload the data, and for some period of time they may be trying to just share it with just the collaborator. So you don't have to share it necessarily with everyone, just share it with your collaborator. And you can still use all these tools that Jeremy was mentioning, but the data is not visible to other people. But these data, the data that Jeremy was mentioning is probably not visible.
Excellent. Yeah, that's an important point. Okay, so we go to this this DANDI set, and we can click on. You can see that the size of this DANDI set is 1.5 terabytes, and it has 117 files. So I click on the files icon here, and we can see that it's divided into subjects, and then within each subject, you've got sessions. So this system imposes a structure so that you know that every DANDI set is organized in the same way here. So for each session, it's an NWB file. So if I go to the first session and click Neurosift, then we essentially are opening that NWB file in the web browser, and I can begin exploring the contents of this file. So I can see that there's behavior data sets, and I can, one really nice thing about Neurosift is that it just gives you a very quick overview of what content is in the file. Here are some different states, and I can do, like, for example, a synchronized view of the position and the sleep state. And view, and now I can just scroll and just have like a very interactive browsing experience here. Okay. Okay. So let's look at the URL that was generated here to go to Neurosift. So if I'm here, I can see that it's neurosift.app, and then there's a URL query parameter, and that points to this NWB file that's on the DANDI archive. I know that's very small to see up there. It's a little larger here. So you can substitute that URL with any URL of a remote NWB file, which is HDF5 format. So again, there's no server-side component here. You can just point it to a local file or a remote file, and Neurosift will lazily load the data from there. So the significance here is that this file itself might be 100 gigabytes in size, but very quickly we're able to, it only downloads the pieces of the file as you request them and as you navigate. Was there a question? Oh, yes.
So you have an NWB file and then it gets converted to an HDF file?
No, NWB uses HDF5 as it's like a layer on top of HDF5. So it's an HDF5 file which also satisfies the constraint of NWB.
Which basically means also you can use that. So no matter what sort of platform you're using for analyzing your data, whether you use Julia or MATLAB or Python, you can access it using HDF5 tools, but also there are specialized interfaces that are built for it, specifically for MATLAB, Python, or NWB and MATLAB. It makes it easier if you're using Python or MATLAB. But the other ones you can still use HDF5 libraries.
And I should mention that HDF5 is not particularly cloud-friendly format. So there are some tricky parts of Neurosift that allows you to be able to lazy load data from the remote HDF5 file, and it's not ideal. So later I'm gonna get into some of the pre-processing and shortcuts that Neurosift uses to make this much more cloud-friendly. Okay, so you can actually open local NWB files as well. So I'll just go through this example to illustrate. So this is a DANDI set that has a bunch of relatively small files. So many NWB files are like hundreds of gigabytes. This one is only 6.3, so I'm going to download that.
And while Jeremy is doing it, that's the data, Dandy said 000946, that identified the number for the Dandy set. In each Dandy set, you might have, you mentioned, folders with different subject sessions, etc.
So if I do Neurosift, view NWB, and then, well, I guess I've downloaded this a bunch of times. BH494, oh boy. Just demonstrating the, okay, well, let's see, it's this one. And we'll cross our fingers that this works, so.
That's the JSON.
Yeah, let's pretend it was an NWB. There's a reason it's JSON, but it really should be .nwb. So let's pretend you didn't see the .json at the end. Okay. So now what this is doing is it's pointing to a server that's running locally. So you can either view data sets that are on DANDI remote, or if you download them, when you run the Neurosift view NWB command, it'll create a local server, and then you can use the browser like that. So here's some spike sorting units. All right, great. Okay, so Neurosift is also a DANDI browser. So the DANDI REST API, it's really a great resource because it's open to the public. So tools like Neurosift can just use the API in the same way as the original DANDI site. So if I go to neurosift.app, you probably noticed that it's basically just shows you an alternate view of what DANDI archive shows, just in a different format. So you can search for different data sets. Well, let me just do electrical series, for example. And it will do the DANDI archive search, and I can click on one of these, and it's just a different way to see the same content. Any questions before I move on there? Okay. So as I was mentioning, the structure of an NWB file, so it uses HDF5 as the underlying format. So many of you, I'm sure, are familiar with HDF5. It stores the data hierarchically in groups and data sets with metadata at each node. So it's sort of like a directory system, but it's all in one file. So NWB is based on HDF5, but it imposes further structure. And basically, it's a hierarchy of neurodata objects. Examples of neurodata objects include electrical series, units, behavioral events, LFP, time intervals, etc. So here's a nice illustration of all the different types of data that you can include in an NWB file in this very structured way. So I already sort of covered this, but NWB files can be very large, so it's important to be able to lazy load the individual objects without downloading the entire file. HDF5 is not particularly cloud friendly, so that was a lot of the effort in creating the initial version of Neurosift, was trying to figure out how to, because HDF5 reader, as far as I know, the one that all software uses is this C program, or a C library, and you can't run C code directly in the browser, but you can compile it to WebAssembly. And then so Neurosift uses a WebAssembly compiled version of the HDF5 reader, and it uses that in a worker thread. And there's some tricks with synchronous versus asynchronous retrieval of data from the remote system. Usually when you have like a web browser, all of the images on the website are asynchronously downloading. Whereas the HDF5 driver, it really is assuming that you have the file locally and it's synchronous reads during the thing. So there were some tricks in trying to figure out how to get the WebAssembly code to do synchronous reads to the server. So you may or may not be interested in all that, but that's sort of the background of how it's able to read the remote HDF5 files. But you mentioned, you noticed that there was actually a .json file. So what really speeds things up is pre-indexing of all the public Dandy sets on Lindy. So if you think about it, the HDF5 is a binary format. All the metadata is sort of scattered throughout in a way that's difficult for a web browser to retrieve, right? Because each request might get a megabyte of data, but the metadata might be all throughout the file, and you'd have to make many requests to get that. So what Neurosift does is it pre-indexes all of the public Dandy sets and creates JSON files for those that summarize all the metadata, but still contain references to the original HDF5 file for the chunks of data.
Will you show them a little bit of the big picture you see with Neurosift of the internal metadata structure?
Sure.
What I think now we know.
Yeah, so I'll get to that, but yeah, so there's, maybe this is what you're referring to. So if you go to the raw tab here, this is the hierarchy of the HDF5 file. So each of these is a group in the HDF5, and then if I go, right, and then for each of that you have subfolders or subgroups here, and then each subfolder it nests down until you get to, usually there's a data set. So processing, behavior, linearized position, spatial series, data. So this is an array of size about 1 megabyte. So you can see that there's a lot of, so HDF5 is a very general kind of container format, whereas NWB imposes all this structure on top of it. So for each of these groups, you've got attributes, and each neurodata object has a certain neurodata type, an object ID, et cetera. So you don't have to worry about this because the software you use to convert to NWB handles all of this directly. You just give it, okay, I want to add an electrical series, I want to add a spatial series, and then internally it will create this hierarchy.
Which also means that when you want to read the data, for example, you're looking for LFP or spikes, you have to use a very specific syntax that is uniform across all these different data sets. So same thing is going to find the LFP file for you for spikes and such and such. So that makes it very easy to utilize the set of code that you have that you use for one data set to another data set.
Right. Okay, so this pre-indexing of the Dandy sets, you may or may not be interested in this internal. The main thing that the takeaway is that Neurosift loads things very quickly. But here's an example of a 137 gigabyte file. And notice this little annotation here called using Lindy. So what that means that it recognized that this was a public asset on Dandy archive, and then it looked to see if it had pre-indexed that in a JSON file. And in this case it did. And if I look at the, what it's actually loading is this JSON file here. And I don't know, to me it's very satisfying to view all the metadata in one shot. But you can see that it's all JSON format, and then it contains references here. So when it comes down to actually referring to a chunk of data, that's not going to fit nicely within a JSON file, right? So there's external links in this format back to chunks of data in the original HDF5. Question?
Yeah, for this IDL example, from what I remember, IDL has their own kind of storage and API. Were they originally stored as HDF5, or have they converted it for storing on DANDI?
It is HDF5 NWB on DANDI.
Yeah.
Yep.
All the physiologists say that.
Yeah.
But they also have other genes, behavioral physiology. So it's the case for like microns is sort of a transition base. It is the old Dandy, but for example, for microns, which is basically the faster extent.
Yeah.
Yeah, exactly. So for that one, the imaging data is on VIL, which is another repository for the images, but all the physiology data is on there.
Okay, so you can also access these objects from Python using various Python libraries, including one that's called PyNWB. So we go to our example NWB file, click on processing behavior sleep states. So go to processing behavior sleep states. So I've opened that object. Again, it's you can interact with it. And then on the left, there's always this load in Python button where you can conveniently just copy that auto-generated code. And by the way, who has been able to get onto the Dandy Hub? Okay, excellent. So if you are interested, you can copy that code and paste it. Let me see if I'm actually on Dandy Hub. Okay, it looks like I am. So let's make a new notebook. New notebook.
Sorry, just to be clear.
Yep,
Nothing you've done up to this point has depended on Dandy.
correct.
Okay.
Yep. Yep, everything is just available through the web browser. So I paste this code in, and no module named Lindy. Okay, because I didn't follow my own instructions and do that initial install. So let me do that. Okay, great. So let's try this again. Okay, so you see how quickly that was. I now have objects for the start time, the stop time, and the ID fields there. So then going back here to my document, where was I? Okay, so I can then add this line, print label. So this is in addition to what was automatically generated from Neurosift. And you can see now I have all the awake and non-REM states available in the notebook. Okay, so let me just go quickly through the different Neurosift tabs. By the way, I was sort of having fun, and I created this chat button here. So this is a peer-to-peer ephemeral chat. So if you type in something there, I don't know how useful it will be, but if somebody has a link that they want to share with the rest of the group, that hasn't really been tested very much, but it was kind of a cute and fun idea to make that chat. But it is peer-to-peer, so the data is actually stored on everybody's computers if you open the chat window, and not on like a central internet place. So, all right, so let's go through the different tabs. So we got the NWB tab, which is what we saw. We saw the raw tab here. There's the widgets tab, and this basically automatically goes in through the whole structure of the NWB file and finds out what are all the visualization plugins that are relevant to this file. So I can go to the XY spatial, and we can see all the different objects within the NWB file that are eligible to be viewed with this particular plugin. I'm not sure why it's not exactly working, but I'm not gonna, so time intervals, click on that one. Yeah. Okay, so that's the widgets tab. Specifications, okay, this is a nice view of all the different neurodata types that are stored in the spec section of the NWB file. So if you're interested in going and looking at all the different types of data that could be stored in an NWB, that specifications tab will show you that. Dendro, I'm going to get to that a little bit later in the presentation. And then annotations, this was an experimental feature where you can add public annotations to different DANDI sets or NWB files. That might go away. It's just, I was trying something out. So feel free to give your feedback on that feature.
Before you
Yep.
Chair, so just one thing for you guys to know is that the idea of the NWB is that you have your raw data stored in the NWB. You could also add process data
Right.
to the same file. For example, you may have the raw, so the idea is that you don't touch the raw data after it's stored first. So you do any additional pre-processing, etc., is going to go under different categories. That's why you see this with tabs here, like the raw.
Exactly, yep. So for example, this is an electrical series that's part of the acquisition. Well, maybe it'll take a little bit of time to load that. Okay, yeah, so I can view 30 channels at a time. Yeah, so that's the raw acquisition, and then as Nima mentioned, then there's sort of derived processing from there. Okay. Any questions about the structure of the tabs on Neurosift? Okay, so there's another feature of Neurosift, advanced DANDI queries. So if I go to the homepage of Neurosift, I can click on advanced query, and let's say I wanted to find a DANDI set that had certain neurodata types. So for example, units and electrical series. And now what this does is it shows all the DANDI sets that have those data types in them. And if I select some of those DANDI sets, I can do a further query using either JSON path or other or JavaScript queries. So submit the query, and what this particular one does is it returns all of the neurodata types for each of the files in those DANDI sets. So that can be useful if you're looking for examples of existing DANDI sets. All right, so let's go to a particular example, and we can actually move towards being able to process some of this data. So on DANDI archive, we can go to 000458. Close all these tabs. Close other tabs. Okay. 458. If you want to read a description of what that's about, there's a link here. But essentially, we've got electrical series, LFP, epochs and trials, and then running speed for the behavior, and then units, output of spike sorting. So, if we click on the units section, we can view a raster plot of that. Okay, let me go to one of these examples. Files, open the first file, open with Neurosift. And we'll go to, this particular one doesn't have any units. Maybe this one does. Oh, I'm not sure. So which was the one?
That's, I've seen that there is a different has units.
Yeah.
They could be kind of subject.
Okay, so this example has units here. So I can go to raster plot here, and so you can get an idea of the spike events in this data set. So there's 607 units altogether, but of course in the raster plot you can only view about 27 at a time. So let's say we wanted to get some more insights on this data set. Well, there's this peristimulus time histogram visualization plugin in Neurosift. So what we can do is to follow those instructions, we can go to the trials table, oops, back to main, trials table in the intervals, and click on the PSTH. Here I can group trials by behavioral epoch, sort units by location, and then as shown in the instructions here, what we want to do is put a trial filter. So only consider those trials that have is valid equals 1, is running equals 0, and the stimulus type is electrical. So in this experiment, they applied different stimuli, some electrical, some visual stimuli to, I think it was a rodent. So now we've filtered that out, we can select all these units, and it will generate the PSTH for each of these. So you can look for patterns. This kind of vertical line here represents the time of the stimulus, and then each column, each row is the spike train for that. So if we go down to unit, oh, and by the way, one step I didn't do, which is in the instructions, is to select, because I think the stimulus was applied to the motor cortex area, and so where you see the most effect is in these motor areas here. So you can see in this case, there was a decrease in activity after the stimulus, and then it recovered after a certain amount of time. I can click on select units to automatically select all the motor units.
Is that also loadable in Python with the Lindy, or?
You can load, yes, you can load this, the trial structure and everything in Lindy, but it doesn't generate the PSTHs at this point, yeah. So if I go down to unit 500, this is one that shows this pattern that's featured in the paper, which is you have a decrease in activity after the stimulus, followed by a sharp increase there. So again, this is there's a published paper associated with here, but without being able to see the data and drill down, there's only so much that the paper can kind of illustrate within a couple of static figures. So this really gives you a chance to go in and view the units and look for the different phenomena. If I change the trials filter to visual stimulus instead of electrical, then you can see that the pattern does not exist in any of these units. So being able to kind of come up with questions and answer them there is powerful. Okay, so that's the PSTH is another example of a Neurosift plugin that does not require any calculation on the server or anything. It's just pulling data directly from the remote NWB file. But sometimes in order to get further insights on the data set, you need to run some kind of Python process or script. So that's where Dendro comes in. So as I mentioned, most of the time Neurosift doesn't require this, but let's say that we wanted to be able to view the autocorrelograms for the units. So in that case, it's too computationally expensive to pull down all the spike trains into the browser, compute the autocorrelograms, and then render them. So in this case, we need to have an external process. So let's go to that example, and we'll go to the units window here. and then click on the unit summary tab. So in this case, we can see that this Dendro job, which computes the autocorrelograms, was already submitted by somebody else. And so we benefit from that and see the autocorrelograms. But if nobody had previously submitted that Dendro job, then anybody could go in and create a new job. So for example, if I wanted to change the parameter and have a bin size of 0.5 instead of 1, then I could submit this job, and then I enter my Dendro API key. So that can be obtained by clicking here. You basically have to log in with GitHub, generate an API key for your user, and then paste that in there and submit the job. And now you can see that this job is pending. And there are some public compute resources that are available. It's actually a limited public resources, but there's also ways to use your own compute resources to run these jobs. So what I was planning to do is have those of you who are logged into DandiHub to go through the steps of starting your own Dendro compute resource on DandiHub, and then going back to one of these data sets and queuing up the job queuing up this Dendro job, and then seeing that it actually runs on DandiHub. So are you guys up for this task? Okay, raise your hand again if you are on DandiHub. Okay, excellent. All right, so let's give this a shot. So let's go back to this tutorial here. Oh, and by the way, so in this particular case, where this job is running, oh, look at that, the job failed. Well, I'm glad that it failed, because it will give us a chance to see the ability to diagnose the issue. So if you click on the job ID, it brings you to this Dendro summary page where you can see the name of the processor that was used, the name of the Dendro app that was used, the status, how long it took to run, as well as the required resources for running the job, the inputs and the outputs, as well as the parameters that were used. So if I look at the console output, we can see that there was a division by 0. And I think the reason for that is because I specified that the bin size was 0.5, and my suspicion is that that got somehow rounded or truncated down to 0. So, but the one where the bin size was 1 did work, and you can click on that job ID to see the console output for that. You can see how much time elapsed and the compute resource that was used to compute that. Okay, so let's see if we can go through this task. Now, this is exciting because on DandiHub, once you have a Dendro compute client that's running, then we immediately have a shared pool of resources. Right now, the one that ran here was just on my workstation back at Flatiron Institute. There's only one public resource right now connected for demonstration purposes. But okay, so let's go through these steps. Okay, so you can see here there's the Dendro API key, and if you don't specify a compute client when you submit the job, it will just put it into the pool of public resources that get picked up like that. But you can also insert the ID of the compute client that you are targeting. So, okay, so let's go to DandiHub. And what you're going to do is make a new directory called Dendro Compute Client, change into that directory, and then just run this one command, Dendro Register Compute Client. So let me do that on my DandiHub instance here. By the way, this hasn't been tested with this large number of users, so 50-50 chance that that things will work out. Okay, so I'm going to make directory Dendro Compute Client, and I already made one of these earlier, so I'm just going to put client 2. All right, so then you run Dendro register, oops, register compute client. Okay, for the name of the service, as it's shown in this document here, we have to put in Hello World Service, which is right now that's the service that Neurosift is using. The unique name for the compute client, so I'm going to put in Magland Dandy Hub 2. But you can choose your own unique name for that. And then it tells you to go to this particular link to actually register the compute client. That will require logging in using GitHub, and then click Register Compute Client. That will give you a code, which you then paste back into here on Dandy Hub. And then you can click on this link to configure your new compute client. So the things you can configure are basically the resources that this compute client has. So on Dandy Hub, we certainly have, on your instance, you certainly have 4 CPUs. I think it's probably more than that. But just to be conservative, say like you're saying that this compute client is capable of handling up to 4 CPUs, no GPUs, and this is the time limit for how long a job is allowed to last, etc. So by default, this compute client will process jobs for all users, but if you want to only target your own user, for example, then you would click here and put in your GitHub username or the usernames of those that you want to share the resource with. Okay.
Jerry?
Yes.
I tried yesterday.
Yes.
To register, so I had already registered.
Yes.
But I don't have the link anymore. Is it in the YAML file or? Because it failed. I tried to re-register and it says, oh, but this is already registered.
Oh, so you could always register a new compute client. Is that? Oh, you want to be able to go to configure it?
I just tried to follow again the same procedure.
Okay.
Then I got an error.
Oh.
Because it says this directory is already registered.
Oh, just make a new directory. Yeah. All right. So who is following along and has been able to get to this point? Okay, 2 people. What happened with the rest of you? Did you give up?
I'm logging because my GitHub account is not registered using my email, and now it's very difficult to get whatever way to get a user account.
Later you can send me your GitHub.
Yeah.
Your GitHub ID.
Yeah.
You put the code just.
I couldn't. It directly goes to 404 the text and not my email account.
Okay. So at least we have a couple people that are following along here, so that's good. The rest of you can watch while I do it. Okay. So, all right.
Yeah, it wasn't approved.
Once that has been registered and configured, then you can run this command here to start the compute client. Okay, so here,
That was not the plan.
Did you make changes to the configuration? I missed that part.
yes, you can, if you click to edit the configuration, then there are things you can change.
Or
What's that?
did you make changes? Are we supposed to make changes?
You don't have to make changes.
Okay.
No.
I just missed that.
Jerry,
Yes.
Is this part supposed to only run on Dandy account, not on local?
You can run it locally too.
You can run the local.
Yes.
Okay.
And let me just clarify that this is advanced. It's really not required to use Neurosift and Dendro. So I don't want to scare people to think like if you want to use this, everything is browser based. The only issue is that if you queue up a whole bunch of computationally demanding tasks, it doesn't make sense to have like public resources that are trying to serve everybody. So this is the procedure that is used, that people can bring their own resources if they want to be able to do that. Yep.
Then related question, if I want to run it locally, is there, has
the system requirements.
What are the needed dependency in this tool? For example, I keep running into trouble. The most recent thing I try to follow is that in this register computer client problem Y, then this UTF-8 cannot show the Y to something.
Okay. Well, it's been tested on Linux, and ideally it should work on Mac as well, but I don't use Mac, so it's...
Okay, then I'll try and
Yeah, yeah. But there's no reason why it shouldn't also be able to run on a Mac. Okay, so then I run this container method equals apptainer, and then Dendro start compute resource. Now it's running. I can copy that compute client ID here. And now let me go ahead and try to find a different session that does not have autocorrelograms computed yet. So I go over here, open one of these files, click on units, units, unit summary. And now I don't see the autocorrelograms for this example because nobody has submitted that job yet. So I'll click submit job, and I'll put in not only my Dendro API key, but also the compute client where I want it to run. And click to submit this job. And then over here on my Dandy Hub, did that work? Okay. Over here on Dandy Hub, it is now starting the job. And you can see the steps that it takes is it pulls down the container from Docker Hub, it builds the apptainer container, and then it pulls down the job from Dendro, like all the parameters and everything that it needs, and then it executes that in the container. At the end, it uploads the results to Dendro. So all of those things are automated. Ideally, there shouldn't be any dependency on the particular environment that you're running it on because it uses apptainer. So let's see, going back here, we can see that this is pending, completed, and now I can see the autocorrelograms. So that's kind of neat. Use Dandy Hub as a compute resource. And then has anybody else been able to get to that point? Well, almost. All right. So again, I don't want to scare people. You don't need to do this in order to use Dendro and Neurosift. Ideally, we'll have public resources that will allow you to do all the basic things. But this is how to solve the problem of a lab wants to use their own machine, wants to use their own resources, doesn't want to put a load on the public system. And then there's this mechanism for doing that.
Did you enter anything on the compute client?
I'm sorry?
Like there are two fields. One is the Dendro API key.
Oh, API key. And then compute client, you paste in the client ID, which is this,
Okay.
when you run the compute client, you get that
API
ID.
key is what?
Oh, the API key, you've got to get that from, okay, create new job. You got to click on this Dendro API key, and you should save that in a text file or something. But you need to log in with GitHub. So to me, it's very intuitive, but I can see how there's a lot of pieces that are kind of flying in from all different areas. But essentially, the user just finds a data set that I would like to use a 500 millisecond window. They would just submit the job. And if they don't have a compute client, they just use the public resource and submit job, and there it goes. There we go. Okay.
The share tab, does this work for the output?
Yes.
Let's say if someone runs something on the shared files.
Yep. So you can click Share tab, copy that link, and then you go to share that with somebody, and then it takes them directly to that. Well, in this case, it didn't go to the unit summary sub-tab, but it brings you to that same one. So here you can see that one job is completed with the 100 millisecond window, and then the 500 millisecond window is still running.
That's mine.
Oh, excellent. Okay, so then I can select that, and I'm always really excited about being able to see the console output. There it is. So, and it looks like the job is complete now. So,
It keeps failing.
uh-oh.
There's such files
Oh, yes, so you gotta, when you run the Dendro compute client, you gotta put in container method equals apptainer space, as in the document there. Yeah, so this can work with either Docker or apptainer. The default is Docker. Probably I should later make the default be apptainer.
Question about the peristimulus
Yep.
things we were looking at. Was that supplied by the original group, or is that someone has gone through and done that?
That's automatically computed by Neurosift. So all it needs is the trials table and the units table, and then it puts those together.
So once you upload a data set, there's a set number of routines that run? Is that
It doesn't have to run any, that processing is done in the browser. So there's two types of visualizations in Neurosift. One that does not require any Python script or any back-end processing, and the other that, that does. So peristimulus time histograms actually is one of those that everything is done in the browser.
Jeremy,
Yes.
actually, people can also export the parameters that we used for a given calculation.
Yes,
That if something acted on.
right, right. Question? Yeah.
So there is PSTH computation, and then you have things like within Dendro, autoparallelogram is like readily available as a feature. But let's say I have to do a new thing. Is it possible for me to just put in my Python code or something?
Yes, that's a great question, and we'll get to that, especially in the context of I've been working with Vincent on dataset 363, and there's an example where he had custom processing, and then we imported that. Okay, so did we cover this yet? Yes.
One more question.
Yep.
So let's say I do this analysis. Is it possible for me now then to get back into that database where, because when you show the original NWB data set,
Yes.
there is the acquisition and then the processing. So is there a way to then say, after I computed the autoparallelograms, those can also be saved as processing
Yep.
nodes as well?
Exactly. Yeah. So
Not on a data set that is not yours.
yeah.
No, I'm asking for mine.
Oh,
Yeah, so if it's your data set, then we don't fully, I'll get to this later, we don't have the full cycle in place for Dendro and Neurosift yet where you can just click to upload back to DANDI, but that's the idea, that when you run processing, it adds objects to the NWB file, and then once you're satisfied, okay, I want to share this, then ideally there should be a button that then uploads those new NWB files with the new objects in them.
And once I make my data set NWB, is it automatically public, or I can only do it at the very end when I've done all the analysis?
When you create a DANDI set, you can choose either public or embargoed. And I guess the idea with embargoed is that after publication, you would then make it public. And yeah, for embargoed mode, you can, only people that you authorize will be able to have access to it. Okay. So there's this provenance tab in Dendro. So let me close these other tabs here. So if we go back to this example and we click on the Dendro tab, you can see which Dendro jobs were used that had this particular NWB file as input. So you can see we did unit summary 3 different times, but 2 of them failed. And then there's this Zebra processing, and I'll get to that. But basically you can see, if I click on this output, it brings you to the downstream NWB file that now has the new object in it, this Zebra calculation. And then given the downstream file, I can also click on the Dendro tab and see which files were used to produce that one. So you can kind of like go back and forth within Neurosift. And then, of course, for every job, you can drill down and see what parameters were used for that particular processing. Okay. Okay, so here's another example, Zebra embedding example. who's familiar with the zebra processing? Yeah, a little bit. So it's a machine learning technique that takes your neural units and spike trains and embeds them into a low-dimensional space that you can then correlate with the different behaviors or for decoding behavior. So let's take a look at this particular DANDI set 140. And so we have a trials table, spatial series objects, and 142 neural units. So we click on the units link. Okay, 140 files, open with Neurosift. So I click on the units, and then there's a Zebra tab. So again, this is like hard-coded into Neurosift, but later we can, once we create new processing techniques, we can also put them in as plugins. So we click on Run Zebra, the number of iterations, the batch size, bin size, so different parameters that are specific to that, and submit that job. So in this case, so this one is pending, but we already had a couple that had completed. So if I click on this embedding, you can view the output in Neurosift. And now this, as I was mentioning before, this NWB file has references to all of the objects that existed in the original NWB file, but now it has additional objects that have been added here. So this embedding object, which is a time series with 10 dimensions. And let's see, there we go. So let me view the first 5 dimensions. All right, so the neat thing about this particular example is that the trial structure is sort of periodic, and that is actually captured. I can view these 2 items in synchrony here. Right, so the trial structure is periodic like this, and then the embedding also follows that pattern. And I did not give the behavioral information to Zebra for the embedding. So it's kind of a nice illustration that it comes out like that. All right, cool. So this is nice in that anytime you have a units table in an NWB file on DANDI, you can click to run Zebra and immediately get this embedding. Okay, so this brings me to this file format called Lindy, this project with Neurodata Without Borders team. So in this last example, the input was an NWB file, and the output was the new NWB file with additional objects added. And this is sort of very intuitive, and it's great because then you can always reference previous files, and like, for example, a PSTH, if you run spike sorting, you'd immediately be able to have access to that, the original trials table plus the new units. So it's very important to be able to have everything in one file. But the problem comes when some of those data sets are very large. So like, for example, with raw ePhys data, it can be like 100, 200 gigabytes. You don't want to duplicate that data in your downstream NWB files. So that's where this Lindy format comes in, where you can have an HTF5 like file that has new data in it, but then has references back to the original data. So I don't know if I'll go into too many details here, but if we let's load that embedding. So let's go to this particular example. And go to the embedding, load in Python, copy this code here, and then go to the Jupyter. Oh, it looks like I've closed my Jupyter Hub. DANDI Hub. Okay, well, I can also do it just locally here. Oh, there we go. Okay, let me do it over here. New notebook. So very quickly, I now have access to this embedding, shape 14683 by 10. And the significance here is that this URL is pointing to a file of type nwb.lindy.tar. So this file itself is very small because it only has the embedding. So if I go like curl temp.dat, so if I download that particular file, it is only 2.9 megabytes. But it has pointers to the original HTF5 file. So if I open it using Lindy, I can now treat this file here as though it's an H5Py file and access all of the objects lazily and pass that HDF5-like object into PyNWB. So anyway, so that's the idea of Lindy. It's not, it's still sort of in flux and in progress, but the hope is that either this or something like this would be eventually supported by NWB and DANDI. Okay, so here's another example, viewing DANDI AVI video files. So DANDI supports uploading of AVI files, but currently there's no way to preview or stream those types of files in the browser. You can stream MP4 files, for example, but browsers don't support AVI. So let's click on this example here. And the way this works is that there's a Dendro job, and so Dendro really uses memoization as a core part of it. So the idea is that as long as we limit ourselves to only certain discrete set of parameters, then you can think of every Dendro job has either run or hasn't run. And then when you want to view a particular video, if it hasn't been run by somebody else, then you click to submit the new job. So here, submit the job to run. This data set, you can only view the first 10 minutes of it, but I could click to run. I could request 30 minutes, and well, it looks like that job has already finished as well. But you get the idea that if there's an AVI file on DANDI, you now have a mechanism to run a Dendro job which prepares an MP4 file, and then you can view that and preview it in the browser. Okay. All right, and now it says, note to self, determine whether we'll have time to work through these examples. So I don't.
We have one too.
Yeah, okay.
Especially at 360, I think.
Yeah, maybe I'll go on to this one and then we can come back to this if we have time. Okay, so 363. Okay, so this is one that Vincent brought to my attention, this mesoscale activity map data set. So what does it have in it? You can click through it and view this in Neurosift. We can see that there's some position, behavioral time series, jaw tracking, nose tracking, tongue tracking. These are outputs from Deep Lab Cut, and you can click to kind of see what those look like. There's also a table of trials and spike units. So the task from Vincent was, can we create phase time series for each behavior and add it to the NWB file, and also generate phase tuning curves for each unit and record the tuned phase and the p-value in the units table. So this is kind of going to your question about custom processing. So how is that done? So Vincent had some Python code, and so we created this special Dendro function to perform these tasks. So here's the source code for that function. Now, it's not always easy to view somebody else's source code, but basically the way that you define a Dendro job is you create this Python class that it's a pydantic class that defines the input and the output parameters. So we have an input file, which is supposed to be an NWB file, an output file, which is also going to be NWB. Actually, it's going to be a Lindy format so that it can contain references to the original input. There's the units path, the place in the NWB file where the units are, behavioral paths, dimensions, and some other parameters here. And then you have another class which represents the processor or the processing function. And in a run method, which receives the context in the input and output parameters. So this is the code that actually makes the computations. And then in the end, so it's basically modifying the NWB file here. And then it uploads the results using this command context output upload. So to answer your question, it's very possible to just create a custom processor. You then also have a Docker file that's associated with your processor or your app, which has all the dependencies that you need.
So the main thing is when I create the script, if you go back to that,
Yep.
is that at the very top I've had something like from Dendro or so?
Yes, from Dendro SDK.
I see. Okay.
Yep. Yeah, so you create this, you create a Docker file, you push the Docker image to Docker Hub, and you include that Docker image right here in the definition of the thing. And then you got to go to Dendro and register that app. So in this case, here are the apps that I have registered. Hello Neurosift is the one that has this special analysis for 363. But once you have uploaded to Docker Hub and pushed your source code to a repository, you can click this update from source and it will register all that new code into Dendro. It will then be available. Okay, so that's the side of creating the Dendro processor. Then on the other side, we need to be able to queue up these jobs. Now, there's nothing in Neurosift right now that is specific to dataset 363 and this processor function, so it's not as easy as just going to the Neurosift and clicking, process. So there's a different way that you can queue up jobs, which is to use a Python script, a driver script. So here I'm going to create the job definition, which has the input file. Here's the URL of the input NWB file. Specify the parameters, and then run this submit, specify the required resources, and submit job. Once the job has been submitted, actually, let me just copy this and go over to our Jupyter notebook just to illustrate that we can run that. Okay, Dendro API key must be set. All right. All right, I have it set on my local computer, so let me run it here. Okay, you can see that the result of running this was that it gave me a link to the newly created job and the status. So I had run this before, so the status is completed, and I can click on that job, and you can see that it's there. And here's the console output. I love looking at the console output for some reason. And then, now let's say I wanted to see the results in Neurosift. So what I do then is I go to the 363 data set. Click on the particular session that I was processing, go to the Dendro tab, and we can see that the tuning analysis was generated with this NWB file as the input. So I can click on the output of that, and then that brings me to this NWB file that has, so here's the original acquisition with the jaw tracking, and now I've got new neurodata object called jaw tracking phase in the processing section here. So I can click on that, view 2 items, and we can see a synchronized view of these 2 things. And let's just verify that it looks right. All right, so this is the X and Y. So this is the movement, and then this is the computed phase of that. And then in addition to the phase objects, we can explore the units table, which existed before, now has new columns. Jaw phase mean, jaw phase variance, p-value, same for nose, etc. So all of this new data has been added to the NWB file. We can then go to it, use different tools to analyze this as though that had been in the DANDI set originally.
Question.
Yeah. Oh, there we go. Oh, we both have questions.
Yeah, I was just curious, are we seeing each other's Dendro jobs because we're on the same service, or is it conflared with like a previous jobs?
That is a really good question, and let's discuss that in a minute. That same question. Yes. Now, there's obviously a big trade-off here, right? I mean, labs are used to just having everything internally. They don't have to worry about everybody else seeing their own jobs. So this, I don't have a great solution to this, but the philosophy here is that every job exists. It either has been run or not, if that makes sense. So if you have a set of parameters that you want to run, now there's another question about privacy, about whether you want people to be able to see the output of your jobs.
To me, it was less about privacy, just thinking of my own self. Like if I'm debugging something, I might hit run like 50 plus times a day.
Sure.
Able to change and the code fails again and again. So I imagine if multiple people are doing that,
Yeah.
it's going to end up with like a
Yes.
mess.
So one way to kind of address this is to have tags. So Dendro jobs can have tags associated with them. So right now, jobs only appear in Neurosift if there is a Neurosift tag. So you can run things, if you don't want them to appear in Neurosift, you just leave out that tag. But we could also have other, tag it by lab or other things like that, and then be able to filter. So I don't have like a full answer to that question, but I'm hoping to get to the point where we have too many jobs being created. Right now we don't have enough, but yes. Other questions?
You want tag because you do extra jobs, but at the end of the day, the stuff, I need that curated, and then this lab's name, for example, and then you guys can just give the images of that stuff.
Yeah.
Someone clean up failed jobs after like 7 amount of time or something.
Right.
Exactly.
Yeah. And I'll mention that if it's an embargo data set, you can do all this and nobody else will be able to see it. Question?
Is there an easy way to export your plots?
Yeah, well, the table you can easily export here by clicking on this download button, and it outputs the table in CSV format. In terms of the plots, right now there's no export as PNG button, but we should add that. All right. All right, so we went through all of this. Okay, so finally we get to spike sorting. Now, the problem is that spike sorting is challenging, in all caps, due to several factors. One is it's resource intensive. Kilosort requires a GPU, takes a lot of time, storage. There's a lot of parameter uncertainty, so there's really no consensus or clear guidance on what the optimal choice is for the parameters based on your type of data set. And there's also the whole question of like, okay, I did spike sorting, I got a whole bunch of spike trains. How do I get an idea of whether this is actually a reasonable result? But before I go on further, who here is interested in spike sorting? Okay, that's good. I wasn't sure about that. So who here would like it if there was a button to press on a browser to do spike sorting? Okay. So, yes. Yes.
If you would want that button to be like Google's I'm feeling lucky button?
That's a very good question. So this spike sorting is actually the whole motivation to Dendro, and the reason that I saved it for the end here is because it's really difficult to develop a system like Dendro using spike sorting as like the example, because it takes forever. And as I said, it's hard to find data sets for which spike sorting, like on DANDI, there's only a handful of data sets that have the actual raw ePhys data plus the electrode geometry that's needed to do spike sorting. So we want to encourage more people to upload that raw data, but at this point, there's not that much of an incentive to do it. But if there was a button, and maybe it should be more than just a button, specify parameters and click the button, then I think that's an incentive to upload. Yep.
So specifically for NeuroPixels data, like the Neurocom tools, will those automatically add the channel map to the
Yes. Yes, they will. Yeah. So Neuroconf didn't exist several years ago, I think, and so there are DANDI sets that don't have the channel information. Okay, so if we do succeed, then Dendro will streamline this process, and you'll be able to have the advantages of being able to spike sort, have the results on DANDI, integrate with other neurophysiology tools, track the provenance, etc. So there's a lot of advantage if we can get this to work. So let's head over to DANDI set 463, and you're welcome to follow along on your laptops if you want. So we go here, open the first session in Neurosift, and we can see that there's an electrical series. You can click on the traces tab to look at that. It's an actual spike in the wild. It's really exciting to be able to see that. And then we can click on the ePhys summary tab. So let me head over there. So this particular example is only 32 channels. So it's a good one to start with, but it's like an order of magnitude less than NeuroPixels. So if I click on acquisition electrical series ePhys summary, so again, this is a Dendro job that has been completed already, which is just the goal here is to summarize what is in this ePhys data set without actually doing spike sorting, so you can get an idea of the firing rates. So these are estimated firing rates over all the channels, and you can see the electrode geometry map. You can also see the power spectra of the different channels, just to get an idea if there are dead channels, which ones you want to be able to select, etc. Okay, then we can head over to the spike sorting tab. And here, spike sorting is basically takes place in 3 steps. The pre-processing step, the actual spike sorting algorithm, for example, kilosort, and then post-processing, which is like computing quality metrics, preparing the average waveforms for visualization downstream. Okay, so jobs that have previously been run, I prepared the ePhys recording, and here are the different parameters that were used. If you click prepare new data set, you can say, okay, for testing, how many minutes do I want to run this for or analyze? The frequency range for filtering, which electrode indices that I want to run this on. Here's a compression ratio. I think typically people want to do lossless storing of the pre-processed data, but these data sets can be very large, and so during development, I have implemented an algorithm that allows you to specify lossy compression for the data sets, so that I don't have to wait like a day for something to save. Okay, again, you specify your Dendro API key and then submit your job. So let me click submit there. And starting, okay. Now that's running. So that's a job that's in progress. These are jobs that are completed previously. Now Kilosort failed, and I think the reason that it failed was because there's only 32 channels in this data set, whereas Kilosort 4, I think, only works when you have 64 or more channels. Mountain Sort did complete, but in this case it only found 2 units, and I haven't really gone in depth too much to figure out why it only found 2 units. But if I click on this spike sorting post-processing and then click on view output in Neurosift, so again, this is now a downstream NWB file that has the original acquisition. It has a pre-processed acquisition in the same file, and then it's got the units in this object called units mountain sort 5. I can then view the average waveforms, the raster plot, the autocorrelograms, etc., unit locations. And then I can also, for example, run Zebra on that. Or you can imagine there would be other downstream processing that you could do. Okay, so there's that one example. Not very satisfying because not a very high channel count. Okay, so now we can try a NeuroPixels example. And this is sort of what I'll finish up with. So we'll head over to DANDI set 409, which is the IBL brain-wide map. And we'll go to the first session. Click on the spike sorting tab. So let's go to this. I have too many tabs open again, so I'll close the tabs. Okay, so I got that. Go to the acquisition, electrical series. So these data sets already come with sorted units, but what we're trying to do is run a new spike sorting on that. So we go to electrical series, go to spike sorting, prepare a new pre-processed data set, mountain sort 5, kilosort 4, post-processing, open in Neurosift. And in this case, we have this kilosort units. Here's the units table. It has all of these quality metrics that were computed by Spike Interface, and it also includes autocorrelograms and average waveforms as part of the output. So that allows you to be able to click on these things,
Just one question.
autocorrelograms.
So
Yep.
this set of units that you see as a separate category in the bottom, that's the original spike sorting that came.
Oh,
from
yes.
Spike, right?
The units at the bottom is the original. So now those are both in the same file, and you could, if there were tools, you could then compare those two. Okay, so then we can click on unit locations and see where those are, etc.
And all still accessible through Lindy for
Mhm. Yep. All this really depends on the Lindy system because you have layers. You've got pre-processing, that's a new Lindy file. Spike sorting, that's a new Lindy file. Post-processing. And then, so each one is referring back to objects in the previous. Okay. And then you can click on acquisition pre-processed. I can click on ephys and units to get a special view, and I can either click on the existing units from pre-existing units or the new spike sorted units. Click on that one, and this is what I'll conclude with because this is the proof of concept that we actually ran spike sorting in the browser or launched it from the browser. And then we have our electrical series. Let me view 30 channels. Channel separation of 4. Zoom in. Okay, you can see spikes there. And then I can sort these units by number of spikes. So let's select one of these there we go. So that is unit number 14. So proof of concept. It spike sorted that one. So let me see if there's anything else. So there we go. So that's an example output. Now you can see that we're still far away from making this practical. The next steps is I'd like to be able to work directly with labs to see if we can get this working on a larger scale. So parameters need to be optimized, et cetera. But I would like there to be like preset parameters associated with each different type of data set. Maybe we need to do motion correction, et cetera. So get that pipeline working so that it is a single button click in that way. And then the next steps for Dendro and Neurosift, I'd like to continue to work together with labs to develop custom processing pipelines and visualizations for all the different types of neurophysiology data. Work towards having Lindy supported in DANDI. And another step, which I think would be really cool, is to be able to take your results and click a button to be able to upload them back to a new DANDI set or to update an existing DANDI set. And I think it would be nice if I was able to attract additional developers to this system. And thank you all for your attention.
All right, so we have a few more minutes for questions.
Thank you for this great introduction to this very interesting tool. Quick question is, imagine like I want to do more than just this math. I want to solve my customized code. You showed the example, but it seems like there is no way to put that into that. So I suppose I need to contact you, give you a Python code, and you will create a new tab somewhere so we can do it just like the unit sample. Is that true?
Yes and no. I mean, you can create your own Dendro service and run everything through that. The only thing that would be missing is, as you say, a button in Neurosift. So Neurosift does have a plugin system, but right now it all has to be compiled together into one bundle. So
if I don't use that, I can also instead just use Python.
yes.
Use your actual core API basically and run everything through your linked thing, and then I can basically get data in my local and I view them either using Python code, custom Python code, or use the Dendro or Neurosift locally.
Yes.
As long as I convert that into the NWB form, I will be able
Yep.
to.
Yeah. So you want to convert your raw data first of all into NWB.
Yeah.
Ideally, you would upload to DANDI as embargoed if you want. And then if you have custom tools, you could create a Dendro processor using Python, create your own Dendro compute client, or use public resources. Use Python scripts to queue those up, up the jobs. Is that?
If I understand, then the key advantage using this pipeline is that because of this linked application that you basically can, you already pre-read those metadata of these very big files, and using these files and use your interface, I can quickly access the data. I can access the data quickly. That's the key advantage of using this.
Yeah, I think it's also a matter of data management, to force everything to go through a streamlined, right. Yeah.
So you show examples which are all based on like Python script or something. So what about like other language support? Is that possible, or is
Yeah, like if you have something that can be like MATLAB or something, if you can get that into a Docker container, then you can have a Python wrapper around that calls the MATLAB. But yeah. For MATLAB in Docker, you can use the MATLAB compiler.
Further questions?
On
Comments?
one piece of hardware is one of the containers is provided by Dendro or MATLAB. So technically you run the same kind of registry there, but it would have to go outside of the Docker app container space. You just have the native execution.
Which we could do as well. Yeah, we could have container method equals local or something. Yep.
All right, so before we conclude, just a couple of points.
Any further questions?
Oh, yeah, go ahead, please.
I mean, the way I imagine using
Do you use Python?
Mainly MATLAB, but.
Mainly MATLAB, okay. Well, we try to make it as easy as possible to do that. So like if you have your NWB file with your results remote, then it's just a matter of loading the Python libraries that will load those objects in, and then you can save them as arrays or whatever.
So you remember
Yep.
the last part, which says basically load in Python. So
Yeah.
that part is part that gives you the ability to get this information.
Yeah, so like this is a units, here's the resulting, oops, sorry. Here's a units table. I can either download that as CSV, or as Nima mentioned, I could load in Python
So that
this
gives you
script.
a read of that information from the data.
Yep.
So just actually, by the for your information, we're recording this, so I'm going to release it on hopefully McGovern YouTube, that you can access it later. Please, reach out to Jeremy whenever you need it. And since that some of you are not familiar with NWB file, maybe we ask Ben Dichter, who is part of NeuroCatalyst developing NWB, maybe ask him to give us a tutorial, and we'll also create some sort of a mailing list for MIT people here, that later you can get information, and we'll send information to you guys about like where you can find all these sort of things. But in general, if you go to NWB website or DANDI website, you can find plenty of information there. And don't hesitate to reach out. Like if there's something that you're bogged down by it and you don't know how to deal with it, like, there's always people who can help you on the DANDI side or on the NWB side. And Jeremy is also, of course, not only he creates cool stuff, but is also very responsive. With that, let's thank Jeremy for this really great session. And I guess we concluded now. And have a good day until the next round. Thank you, Jeremy.
Since you have their email address,
Yep.
I would just suggest sending some pointers.
Yep, yeah, I will do that.
Open scope data book is a very good place to
Absolutely.
look at, or kind of starting on various levels of EFIS and vice processing.
Yeah, in fact, actually, while you're here, and I have your attention for this very moment, this is actually a very good point. So if you look up for Open Book,
Open scope data book.
it's actually called Open Book GitHub Alum, it's this one. Okay, I'll send a pointer to this. This is a very cool set of tools. And if you go to here, this is a fantastic set of routines, how to deal with a variety of data sets, whether it's NeuroPixel, calcium imaging, so on and so forth. And it goes not only about like how to read them, how to visualize them, how to do like simple analysis, and all the way to much more complex analysis. So this is great resource. It's being developed by a number of people. And
And if you have a DANDI account, most of those can be launched directly, so you can even play with them.
yeah. And for those of you who are not able to get your Dandy Hub account set up, go to Dandy Archive, register, and then use the code that Satra gave me, and I sent it an email that you can, we can verify you that you can use it. And please let your colleagues in your lab and let them all know to use these resources. Okay? All right, thank you very much.